Okay, this is section 5.4 in your textbook. We're looking at, again, factoring. This time we're looking at factoring quadratic expressions. Okay, we've talked about what a quadratic expression is before. A quadratic is just an expression where the greatest exponent is a 2, okay, or a square. We talked about quadratic. If you think about a square, it's got 4 sides, and when you think about 4, you think about quad. That's where the idea of quadratic comes in, and this 2 representing a square. All right, so we have a quadratic. So any expression where the highest exponent is a 2, that's a quadratic. So these are 2 examples of a quadratic. The quadratic expression could also just be 2x squared. That would also be a quadratic expression. All right, so 3 examples there of a quadratic. So the key to today's lesson and the difference between today's lesson and tomorrow's lesson, the only difference is that there is no coefficient of x squared. Okay, I'm going to say that again. There's no coefficient of x squared. That's the only difference between today's lesson and tomorrow's lesson. All right? And what that means then is if we have a question that looks like this or like this, where we can see it right away, there's no coefficient of x squared, it makes our job very easy to factor. Okay, because all of these answers then, whenever there's no x squared, you can go to literally one step. Okay, it just takes one step to solve these factoring problems. Okay, there cannot be a negative sign here. There can't be a number sign. If it's just x squared, as long as I have it in the correct order, so followed by the term with just the x variable, and then followed by just the number on its own, I have it set up like that. It doesn't matter what these 2 numbers are, as long as the x squared, I can go to 2 sets of brackets. Okay? So once I've done that now, the first step I want to do is I'm going to write m and a. Okay? And I'll actually refer to this factoring process as m and a. Okay? So get very comfortable with those 2 letters and what they mean. M means multiply, and A means add. Okay, some people might call it product and sum. Okay, you could also use P and S. I use multiply and add just because that's what we're going to be doing. We're going to be multiplying and we're also going to be adding. So it just gives you the operation right away as opposed to using product and sum. I think you're a little more familiar with it. So multiply, we need to find 2 numbers that multiply. You're multiplying this coefficient times this last number. So it's always going to be 1 in this particular case. It's always going to be 1. So 1 times 12 is 12. What adds up to the middle term? 7. Okay, so now we're looking for 2 numbers that multiply to 12 but add to 7. Okay, let's think about this again. There's 2 numbers. When we multiply them, they make 12. When we add them, they make 7. So probably half of you guys, who knows the numbers already? Okay, so half the class already has the numbers in their head. Fortunately, the other half, I'm going to tell you a method to get those numbers. So you don't have to think. Okay, you do have to think a little bit, but there's a process. Okay, so the process is you always take the multiply number, it's always on top, and you divide it first by 1. And just finish that equation. So 12 divided by 1 is 12. Then you look at these last 2 numbers. Can I use these 2 numbers to make 7? And I think most of you can do that in your head. You realize, no, you can't. There's nothing you can do. You can't add them, you can't subtract them, nothing. The next step, you divide by 2, which is 6. Can I use 6 and 2 now to make 7? Closer, but I can't. I can make 4. I could also make 8. Okay, but I can't make 7. All right? Finally, I divide by 3, and I get 4. Now I look at my numbers. Can I use 3 and 4 to make 7?
Yes.
Yes, I can. I can just add them up. Okay? One of the keys to this method, though, is you have to maintain the sign of the numbers. Okay? This is positive 12, and this is positive 7. That's very important, as you'll see later. Okay? Can I use positive 3 and positive 4 to make positive 12 when I multiply and positive 7 when I add?
Yes.
Yes. So my two numbers then are 3 and 4. Those two numbers go here. And the first term is always the square root of this first term, which is x and x. And I said my numbers were positive 3 and positive 4. So that's it. You're done. Okay, so that term is fully factored to here. You take the square root of this term. It's the first two terms of the brackets. I can already populate that, x and x. And then these are your two special numbers that multiply to 12, but add to 7. And this will start to come along as you guys do more examples. So let's try another one. M and A. Okay. So what multiplies to 1 times 6, so it's this coefficient, which today is always going to be 1. It's 1 times 6, so the multiply number is 6. And the add number is 4. Okay. So what multiplies to 6 but adds to 4? Some of you guys might know those two numbers right away. If you don't, you're going to go through this process. Divided by 1 is 6. Can I use 6 and 1 to make 4? No. Divided by 2 is 3. Can I use 3 and 2 to make 4? No. Divided by 3. Can I use 3 and 2 again to make 4? No. Divided by 4 is an uneven number. If it's not a whole number, you don't consider it. All right? Divided by 5. So in this case, that's another uneven number. Divided by 6 is 1. There's no two numbers that I can use, right? Can anyone think of two numbers that multiply to positive 6 but add to 4? There's none. So if that's the case then, I was a little premature with these x numbers here. It's not factorable. Not factorable. Okay, or cannot factor. Cannot factor. And I'm going to tell you guys, this does happen, but it's rare. Matthew?
So you can't use fractions in this case?
No, no. You guys will learn later in this course how to factor this, but for now, cannot factor. Okay, the factors are fractions, you're right. But for now, we're going to see cannot factor. Okay, do not get in the habit of always saying cannot factor, because more than likely, you probably can factor it. Okay, it's rare that you cannot factor it. Okay, next one. X squared minus 29x plus 28. So the first thing we do notice again is that there's nothing in front of the x squared. So if there's no variable in front of the x squared, I can go to two sets of brackets. So it's a one-step problem. I write down M and A. I'm going to multiply to 1 times 28 is 28 and add to negative 29. All right, so this one's a little bit more difficult. Might not know what numbers multiply to 28 but add to negative 29. But if you go through the process that I've taught you very quickly, you'll see right away. Can you use 1 and 28 to make 29? Yes, but there's a problem with the signs, right? If I add 1 and 28, I make positive 29, but I'm looking for negative 29. So what would I have to use then? Gennaro, how do I get 1 and 28 to make negative 29? What do I got to do with the signs of 1 and 28? Yeah, I change them to what?
To negative.
Right, so it's negative 1 and negative 28. So now negative 1 and negative 28 add to negative 29, right? We're good there. But the last step we have to check, does negative 1 and negative 28 multiply to give positive 28? Because that's what we need, right? Positive 28. Does it?
Yeah.
Yeah, so we're good. So x minus 1, x minus 29, or 28. Okay? And this order doesn't matter. You could have put the 28 here and the negative 1 here. Okay? If you did want to check if this is right, you could you could use FOIL, simplify, expand and simplify, and see if we get this answer. And you should. Okay, so you can also check your answer. Any questions with C? All right, D. Again, first thing we notice, no variable in front of x squared. I like to see that because I can go straight to two sets of brackets, where my first term is always in x. And then I do M and A. My multiply, I want negative 18 this time and positive 3. All right, Nicholas, what do I do here?
So you see if 1 divides into 18, negative 18,
Yeah.
and it does equal negative 18.
Okay. Can I use these numbers to make 3?
No,
No. So I got to do what? Divided by?
2.
Okay. Negative 9. Can I use these numbers to make 3?
No,
No. So divided by 3 is negative 6. Can I use these numbers to make 3?
no.
3?
Oh,
is
yeah.
Negative 6.
Yes.
Yeah. So what are my signs going to be then for these numbers? Remember, I want positive 3 and I want to multiply to negative 18.
It's gonna be positive.
Positive what?
Positive, positive 3.
Okay, so this is tricky, right? So the way I have it lined up, it's positive 3 here and negative 6 here. But look, if I add these two, Nicholas, I get positive 3.
9.
Positive 3 plus minus 6, I'm going to get minus 3.
Oh,
So I don't want that. So I want to have this sign be positive, right?
Yeah.
Positive 6. And I want this sign to be negative, minus 3. You guys see that? Okay, because now when I add these two, I get this value. If I had the signs reversed, then I would get negative 3. I don't want that. But when I multiply these two, 6 times negative 3, I still get negative 18, which is what I want. Okay? All right, next. Who wants to try this one? Try Sebastian. What do I do? First thing you always look